All right there, class. We're here today looking at an example. This is a projectile motion type of example. And basically, we have this airplane, a wheel falls off, which I guess would be a very bad day for anyone below it. But I guess for the sake of this question here, we're going to go with it. So what we want to know here is what horizontal distance does the wheel travel, and with what velocity does it hit the ground. Now, important thing to note here, when we talk about velocity, one thing I want to remember here is that velocity is a vector. And because this is a two-dimensional problem, I'm going to need to make sure I have just a magnitude and a direction. And again, this isn't just as simple as saying plus or minus, because again, some kind of vector at two dimensions has both x and y components to it. So we're going to need to deal with the fact that this is a two-dimensional kind of problem. So let's go ahead and see what we understand. Okay, so here it is. Basically, because we're traveling horizontally, this vector here is all in the x direction. So that's why I have it listed here in the x direction. And again, it's not moving up or down, so that's why my initial velocity is 0 in the y direction. We know that it's going to travel along this parabolic path. It falls a total distance of 1.5 kilometers, and that would be our delta y. It starts at the top, falls to the bottom. It's going to be equivalent to 1,500 meters in the positive direction. Oh, I guess speaking of that, if you notice here, I have pretty much all my vectors downwards. So I'm going to simply, for the sake of easiness here, I'm going to actually define my positive direction, my positive y direction as down. And I think likewise, it's just as convenient. Typically, we're going to call the positive x direction this way. So as far as defining positive and negative directions, that's how we're going to do it for this problem. We also know that there's going to be a force of gravity acting on this wheel. And as the wheel falls, it's going to experience that acceleration due to gravity. So you notice here, the gravity is a y direction acceleration only. That does not get put over here in the x direction. In fact, talking about the x direction, because the force that acts on the object, okay, is the force of gravity. It's a downwards direction. There are no forces this way. Okay, that does not exist. There are no forces this way. That does not exist. So the only acceleration that this occurs is due in the y direction, and so therefore there's no acceleration in the x direction. Now that's convenient for us because that tells us that the final velocity is also going to be this 500 kilometers per hour as well. Speaking of which, I do need to convert this. I want to get everything into the MKS system. So I'm going to convert down here. There's my conversion. And so when we plug the numbers in later, we'll make sure we use this number and not the 500. So my goal here is to find find out how far in the x direction this goes. In other words, its displacement. And my goal here is to find this velocity here. Now I mentioned this earlier on, but this is a two-dimensional vector. We have both a downwards component, which I haven't drawn yet, and a rightwards component, which we already actually know up here. So I will draw that a little bit later, but for now, let's get down and talk about strategy. Okay, so to implement what we had said we're going to do here, over here, you'll notice I made a simplification to my equation. And that is because my initial velocity is in fact 0, so this term right here does actually in fact cancel out. So what I've done here is I've done the algebra to isolate time. And as we said before, this is the time that's going to get used here. Now you'll notice here in this equation, this is the x direction, and we've already said that the acceleration is 0. So I've substituted a 0 in, and over here, in this equation, what I'm going to box in right there, that's what we're dealing with right there. So what I've done then is I've actually made a substitution, substituted that in right here for time, since that is in fact the time there. And basically now I'm just going to plug all my numbers in, and I end up calculating a displacement of, looks like a positive 2,430 meters for part A. All right, next we were to have a strategy for finding the final velocity. Now, something to keep in mind here is that final velocity, if you remember my picture, looks something kind of like this, where we have an x component. This would be the final velocity in the x direction, which we already know is the 138.9 meters per second, because, again, that x component doesn't change. We also have a y component, and that at this moment is the final velocity in the y direction. That's an unknown number. So we don't know what that is yet. We're going to actually find that here in step number 3 of our strategy. And then lastly, our last step will be to actually find both the magnitudes and the direction of our vector. Again, because it is a vector that's a two-dimensional vector, simply saying positive or negative is not good enough. So my goal will be to find this angle in here. That'll be my theta that I mentioned down here in my tangent function. So I'm going to go ahead and write this up in my implementation. We'll be back and we'll take a look at what we get. Okay, so what we had said we're going to do here is find the final velocity in the y direction. And again, if we remember back to what we knew and what we understood at the beginning, we would have said this is 0. So you'll notice over here in my equation that I have removed the term, the original velocity term. And once again, I've used the time that we found in step 1. I've substituted that in here. Done some algebra. At this point, of course, I could put numbers in and substitute. But what I saw here was that I could put this term here back into there as an ay squared, and that's going to actually cancel out one of these. So we actually end up with 2 times the displacement in the y direction times the acceleration in the y direction as well. So I find out that my velocity in the y direction is 171 meters per second. Now keep in mind that we already know the x component. We just found this one. What we now need to do is put these together using Pythagorean theorem, and I'm going to use the tangent function to find my direction. So here is what I've done to find the final velocity magnitude. Right here I end up with 220 meters per second, and the tangent function allows me to find the angle. And keep in mind that I am dealing with this angle right in here. This is why this side over here is the opposite. Again, I could have just drawn it over here as well, and this is the adjacent right here. So for a final answer, to respond to what we've been asked to do, we know that it's going to travel, and again, we were just asked for the distance, so we're not really worried about the direction. About 2.43 kilometers. It's going to travel horizontally, and the final velocity is going to be 220 meters per second, 50.9 degrees below the horizon.